we're looking at the way the collections works, interfaces, implementation classes, and some most obviously frequently used types of collections, such as lists, sets, tags, maps, etc. How to interact with the collection content, some automation classes like the collection class and its functionalities, and also we discuss what are the important concerns regarding concurrent access to collections. We'll actually have a later lesson that covers concurrency API in more detail, but in this particular lesson, at the very end, we're just talking about the effect of concurrency on collections as such, yeah, just specifically regarding collections. Anyway, well, let's start with the overview of what the collection API is all about. Now, we've looked at how we can handle a number of values wrapped up in the array. Well, collection API provides much more flexible automation, if you like, for the similar type of task that we could use array for. So how to create a collection of different values and manage it. I would not say that collection is actually physically using arrays inside. That may or may not be the case, and it depends on the type of the collection. But think about it this way. With arrays, you are confined to the array, which is indexed by an integer and is of a certain type, right? But then generally, if you think about it, imagine you wrap up the array into some kind of class. Well, in that case, that class can produce you various automations. And whenever it physically stores values inside as actually an array or not, is kind of irrelevant. The point is you've got the behaviors that this outer class provides to manage a number of items that you wanted to manage. So for example, classes could use generics. You can specify a type of what you want to store in a certain collection. Whilst arrays actually don't use generics. Array is a collection of elements of a specific type. Yeah? So array per se is not using generics. Arrays are not dynamically expandable. Well, you could use system array copy or arrays copy off, but as such, the array itself is not expandable. You just have to programmatically create another array and then copy content from one array to another. But the collection classes, they can do these things. They enable generics, they allow to dynamically expand collections appropriate. They allow you to provide alternative search and index capabilities. Arrays are always using an index. But then if you think about a collection class, well, it doesn't have to use an index. Yeah, it could be more flexible than that. You could perform some validations of elements as you add them to collections. For example, check uniqueness. Yeah? You don't allow, you may decide not to allow duplicates to be stored in certain collections. Order elements in a particular order, provide different operations that manage concurrency and threat safety, and provide mechanisms to conveniently iterate through the collection. Now, the collection API defines a number of interfaces in the collection API, number of interfaces where each interface describes certain aspect or certain capability of collections. And then these interfaces are implemented with different implementation classes, also part of the collection API. And what you need to understand first is what are these capabilities? What are the features? So first you look at the interfaces. And then once you understand what these capabilities are, then you look at which specific implementation class would you like to pick and use on which occasion to implement the behaviors that you require from that or the other collection. Okay, well, let's start looking at the collections API. What are these interfaces? And what are, well, at least some examples of collection implementation classes? Interfaces and the implementation classes of a collection API allocated in the Java util package. And the topmost interface for collection API is this interface called iterable. So it provides a very basic generic features for all collections. For example, an ability to use collections to iterate through the contents of collection using for each loop. So that basically means that because all other interfaces and eventually implementation classes of the collection API descend from that interface iterable, it's like the ultimate parent for them all, right? It means that all collections can be used in for each loops that way, right? Which is great. Now, there's also an interface called collection, which is an extension of iterable, but that is adding extra capabilities to just iteration capabilities, but also adding capabilities such as adding and removing elements. So define how you do that. An interface list describes a collection where elements are indexed by name. So it's kind of very similar to what you get from the array. In fact, the most commonly used implementation class that implements list interface is a class called Arraylist, which is kind of self-explanatory because it feels like an array from the perspective of an integer index behavior. SAT is another interface in the collections API which performs a validation of what you add to the SAT, and it does not allow duplicates. So SAT checks that what you add to the SAT is a unique element, essentially. Typical implementation classes for SAT, hash SAT, tree SAT, sorted SAT. Sorted SAT is actually a variant of the SAT interface, which is implemented by the tree SAT implementation class. DAC describes double-ended cube, which is a collection where you can add elements to top or bottom and remove elements from top or bottom. So with that, you can implement algorithms such as first in, first out, or last in, first out, something like that. Kind of imagine the deck as an deck of cards, and you can draw cards from top of the deck or from the bottom of the deck. Right? That's a typical example of the use of kind of comparison to what you can compare the behaviors of the deck. Then there is an interface called map. Typical implementation for that will be a class called hash map, and that is basically a combination of a set of keys and a list of values. So the map is it's like a table of two columns. That's what the map feels like. Well, the first column in that table is basically a set, and it's a set of unique values, so keys, right? And then the second column in a map is type of list, which just represents any other values you want to put into the map. So that's a high-level overview of the collection API, kind of frequently used types of collections. Now, let's start with Arraylist. Right? So that's the most basic one. It's probably closest to the idea of the array. So Arraylist is a class that implements list elements. It has no arc constructor, which creates a list of 10 elements. However, if you start adding more elements to the list, you will just keep expanding. So you create an array list and you don't specify the size, how many elements, you'll just keep expanding as you add in content. But by default, internally, it sort of pre-creates the storage for future elements to be placed into that array list of 10 items. You may specify specific size constructor with initial capacity. And again, it will grow beyond that size if necessary, automatically. You don't need to do any kind of array copy. It will just do the growth itself. So you can specify a particular size. But I guess from performance point of view, it's a good practice to try to guess how many elements you eventually need and define the size. And you could also, and it's a common feature for all collections, you can also initialize one collection using context. So for example, imagine you previously created a set, a hash set, yeah? You created a set, and you added some stuff to that set, and then you use that set to populate the list. And frankly, that works the other way around as well. So if in one part of the problem, you feel like you want to use a collection with certain properties, certain behaviors, you choose to use list, and then another part of the problem, exact same values, you want to use them in a collection of a different nature, of a different type of behavior, and you feel do like, oh, there, I want to use set. Nice and easy, you can convert one into the other, which is plus the other collection to the constructor of, well, the other collection. Right? So these are the ways of creating array lists. There's also a method called asList. It's a factory method. And the method asList, it's a method of arrays class. Yeah, asList. It creates a list of a fixed size, which is very much like an actual array. Yeah? So fixed size, you cannot resize it. And it accepts an array as an argument for a var arg. It's a fully separated list of parameters. It works too. You can also create read-only instance of list by using a method of list of that creates an immutable list. Right? So you cannot modify it. And as I mentioned, the list expands as necessary. A small caveat when I was saying you can't modify anything in the list. Well, you cannot remove elements from read-only list or add elements to read-only list. But if objects you're storing inside the read-only list are themselves mutable, then you could still modify these objects. You wouldn't be able to add or remove them from the list because the list is read-only. But if the object stored in the list has set something method, well, you can still call the set something method. So contents of the collection and its immutability has nothing to do with the mutability of collection itself. Yeah, collection might be mutable, but things stored inside it might not necessarily. It depends what you want to put into that collection. Okay, so that's the list object. Now let's take a look what are the typical operations we perform on the list. So there is this example, and I would like to kind of zoom into it and explain exactly what these operations are doing. But first, very briefly, we have operations that allow us to add values, update values, delete values, check existence of values, or search for values. Now let's take just a quick look at the details of that algorithm that we have here. So first, we create a couple of products, food and drink, right? And we then create, well, elements. Now, here's some interesting points that I would like to make. First of all, you may specify the initial capacity, but that's up to you. Remember, the list grows beyond the initial capacity. Second, you may constrain the list to use specific type using generics, so to say, and that's list of products. It will allow you to store subtypes of the product into the list, like food or drink. Yeah, they could go into that list. That's what however, did you notice that on the left-hand side I'm using an interface rather than the actual implementation classes? So it's perfectly valid assignment. You can create a variable type of interface and assign to it any object or reference that actually implements that interface. That works. But why am I not actually using Arraylist on the left-hand side? Why is that? Well, I can, but maybe I'll change my mind about the exact type of list I would like to use, because the Arraylist is not the only class that implements the list. There are some intricate variances, and you may wish to use Arraylist on one occasion and maybe some other implementation on another occasion. We'll actually see later in this lesson what are the other variants. Yeah, but polymorphism is general behaviors.
Mira, colores. Mira, ve lo que me queda. Parece a mí. Mira. rompió.
Shh.
And in this particular case, because we use generics, we use
Pero
storage in that list just
esto.
this table.
Esta. Yo quiero hacer eso. Parece que está acá.
Ay. Miranda, estoy grabando.
¡Yeah! ¡Sacaste! ¡Yeah!
Shh. Vaya para allá.
So there's always object reference, and by default they always know. What if I want to store my object? Can I do that? Well, I have to use the reference instead of the list products. I'll say list
¿Es?
individual.
¡Hey!
Stop.
Stored inside that array list refer to the ring objects that are stored somewhere. So list is stored somewhere in heap, T is stored somewhere else in heap, and then the elements within the list are referring to these objects. So they're not null. We just added some content. Now what is going to happen? If I use add method with a designated position. Apparently I can do that as well. So if I say add something to position,
Ven, ven.
Cuatro, no. Vamos ahí. Ahí.
No, ese personalmente para acá.
That will also have a reference and apparently will refer to one to one.
Mami, yo quiero un dulce. Mía.
¿Vas a compartir conmigo?
Es mío, miren, ya. ¿Me puedes dar un chocolate?
Mitad, dame un pedacito.
Ok, listo. Pero,
Dame un pedacito.
ok, pero ¿me puedes usar? ¿Se me cayó? Mami, así, aquí, con aquí.
Dame.
Sí.
The element position 2 will be inserted to reference. In this particular case, it says reference. The previous elements 2 and 3 became elements 3 and 4. Yes? So that's the add onto the position, which is not at the end, but in the middle. That's the beginning. You can also use the method set, and set allows you to actually update the value of the position. So position 2, right? You're changing that from point to reference if you want to reference to next. From to essentially update the value. That's what set is. Now, can I have maybe remove things? Sure. And there are two ways in which you can do it. You can remove elements using an index. So that will remove position 0. Or actually you can remove an element by saying which element it is. So if you say remove element P2, what will happen is that the algorithm will search for the first occurrence of the element in here that refers to the P2 object. Apparently there are a couple of elements that refer to P2. So we'll remove the first occurrence. So the element of position 0 and the element of position 2, these two positions will be gone.
¿Quieres Pepa conmigo? Vamos a ver Pepa.
And the rest of this code will sort of be shifted forward and reused. first two positions are wrong, and then the two positions should be forward. So the list always presents continuously. Starting okay, and what's going to happen if we search and look for something within that list? So there's a contains, yeah? And it tells us something that do we have something that we're looking for? Or maybe we don't. You can also identify which index the element is present. So that looks for first occurrence of a certain element. So in this particular case, Q1 is Q1 is 2, isn't it? So that will be position 2. That's the first occurrence of Q1. So that index will be 2. And then lastly, so location. Yeah, and lastly, we could get elements on a given index. So that will be position 2. And actually, you can just invoke methods upon the object stored in that collection straight ahead. You don't need to extract
No, no,
them
no toques nada, no toques nada.
and it changes the order to
Ven conmigo.
last.
Ya les hago.
Obviously, see the last one is 2. And we've seen before that we can have the position which is plus 1 to the last position. We did it earlier with this last position 2, position 3. That was fine. But what if we try to jump the position? Well, that's the list will insist on actually presenting continuous collection without kind of gaps. Yeah? I mean, you could certainly insert more position. That's fine. That's allowed. But you kind of just jump to position without defining anything. So that will be an exception that will be thrown if you try to do that.